All right, let's begin. Welcome everyone to our last third day of the Bioimage Analysis at Emory seminar series. Today we're going to cover using Labkit for segmentation as a machine learning model and the introduction, and I stress the introduction part of programming macros in Fiji, as well as some tools that'll make it easier, and I link some resources in the presentation for those of you interested. And always remember, we are your neighborhood imaging core. If you need any help, feel free to come to us. Questions and consults are free. So let's begin. We want to learn how to use Labkit, how to annotate an image, how to annotate an image well, because there is a distinction based on the software you're using. We're gonna apply our knowledge from the previous two sessions in order to make use of that segmentation result to calculate statistics. And I'll take you through that, and you'll have an exercise where you can do it by yourselves. So Labkit is, as a plugin for Fiji, very recent. The paper which detailed it and its function was released only last year. So this is some cutting edge stuff. It uses labels, which are labeling the background and the foreground. In this instance, background is not just areas without any signal or areas of noise, it's anything except for the structures you want to segment effectively. So let's go ahead and get started. Go ahead and open the crop composite image. Ugh. Why am I like this? I don't have the right one downloaded. One second. Right, here we are. We can open just right crop composites. Crop composite. This will work the same. So once you have your image opened, this image is several channels. So as soon as we open it, we can split it by channel. We want just this channel, channel 3. We don't need the other two. Once we have that window selected and Labkit installed, we can go down here and open current image with Labkit. At this point, let's take a moment to look through the interface. Up here is the move button. Left click rotates, right click pans. Backwards to the other systems I work on. Your pen here, its brush size is controlled up at the top. The larger the brush size, the greater the area that will be labeled. The same brush size also works for the ruler if you need to correct an errant mark. So how should we annotate it? Well, Labkit utilizes what's called, what's called sparse labeling. And that's basically, while some machine learning software might ask you to, label the entire image in every structure of interest and do it by hand and do it very, very accurately, Labkit wants the opposite of that. It wants just a few examples of the different kinds of background noise you might want to subtract and the different kinds of structures you want to highlight. So as we look at this image, we see maybe a couple of different kinds of background noise. Obviously the larger area and these perhaps internals as well that might somehow be a little lit. And we have maybe 2 or 3 types of signal. We've got structures like this. These are slightly brighter. And then these two are completely different in terms of intensity and geometry than the other ones. So we would need, if we want to mark these as well, if we want the machine learning algorithm to segment them, we'll have to label them as well. So when we select the background and the brush, we can then do just a little line here, a little line here. That gets our 2 kinds of background. And then the foreground, which is where you want your data or your structure to be captured. So we can go like this, and then like this. When doing these, it's important, don't cross a background mark over a foreground mark, because in essence, you'll be telling the software that both you want this pixel and you don't want this pixel, and that will make it harder for it to come out with a good, coherent segmentation. Pardon? Yes. So right now we're just operating on channel 3. Has everyone gotten to this point? Anyone having trouble? Yes. Now that we have our image labeled, have you all labeled your images, or who hasn't yet? All right. Once we have all our labels in place, we can go down here and click Labkit classification and the little start button. It'll say training in progress. Relatively quickly, we'll have the image segmented. Now you all saw this happen very fast. This is a relatively small image and it's only 1 slice. And the larger your file is, the larger your image is, this can even work on a 3-dimensional stack to segment structures you see inside. But the larger the image, the longer it will take. And it's not a linear growth. Like an image 4 times as larger may take 16 times as long to process. So if you ever encounter a situation where you're trying to use the plugin and it's running really slowly or taking a very long time, consider cropping the image you're training the classifier on. The only caveat to that statement is when you crop the image to a smaller portion, make sure that portion contains all of the structures you're interested in capturing, because that will teach the model what to look for, essentially. And at a later point, you can, in fact, save the model you've trained and call it back up in order to automatically process lots of data. So you can do that subsequent processing on a more powerful computer or one of our workstations. We offer workstations designed for this kind of high capacity computing. But we have the image segmented here. If we click the I buttons next to segmentation, we can toggle that on and off. But what do we see? We see that it has captured most of the centers, but not everywhere. Most of this is not captured. It's dimmer than the rest. So we might want to add a foreground marker there. What else do we see? This one is, if anything, under-segmented. We're not quite catching everything. Is there an example of over-segmentation? Here, these are supposed to be 1, 2, 3, 4 distinct objects, 5 distinct objects, but they are being counted singularly. So how can we at least separate these two? Because there is a visible gap there, not quite so much here. So if we're careful with the lowest brush size, we can zoom in and just take a line down through here, doing it carefully. And what we want to do is we want to add another foreground mark here. Mouse wheel, or I think 2 fingers on the trackpad might do the same. The more labels you add at any given any given step of the process, the longer it's going to take to process, because it has to include that new information. So we had a first labeling set. We've labeled it a second time. We see the second has removed the connection here, removed the connection here as well. It's counting this. It's not counting this. It's not counting the center, which is good because we explicitly don't want it to count that. And yeah, these two are very dim. But here, there's nothing that we can see. So we'll do those. And this. We'll train it again. Something you'll notice is the more you train the model and the more annotations you put in, the less responsive it will become. And at some time later on, you'll find that however much annotating you're doing to the image, it's hardly changing the way that it's segmenting the same image. Pardon? Experience. You need to. Yeah, it should be clear once you try it a few times and nothing seems to change. I think maybe around 10 iterations is typically enough to reach a good point. But this is a general machine learning algorithm, so it may not work well for all of your data. You may end up needing other machines or other tools to segment. Does anyone have questions so far? Any concerns or issues? Here are some examples of the correct sparse labeling versus over-labeling images.
So have you seen an issue where as you try and draw on Labkit, rather than letting you draw a line, it just draws a point and then it just moves to another point, even with the brush tool?
Mhm. I haven't, no, I haven't seen that.
For me, it's not letting me draw. No, I've not seen that problem.
Yes. All right, I think everyone has gotten to the point where they've trained the classifier once or twice. Is that correct? All right. So what is the next step? We opened the image in Labkit. We went over the UI step by step. At this point, if we take a look at our pixel classifier here, and click on the down arrow, we have this menu. Here we can save the classifier, and that saves the classifier we've trained. So when we open it, it will segment this image the same way it's segmented now every time. And we can, from this location, export the segmentation results in ImageJ. So if we do that, we get something that kind of looks like a mask. But is it a mask? How can we check? If we try and do a image or process binary convert to mask, it doesn't work out. Well, because this image, while it looks very much like a mask, is not a mask. We can tell that by looking at the background value is 0 everywhere there isn't a signal, but it's only 1 everywhere that there is. So the image it outputs, because of Labkit convention, is very close to, but not quite, a mask that Fiji can interact with. So how can we alter that? Well, we did a lot of it yesterday. We can go ahead and threshold it because the signal is consistently 1 everywhere where there's signal and 0 everywhere else. So should be very easy to threshold. However, not each of the automatic models is necessarily going to pick it up. So it's important to be mindful of that. Because of the way these threshold methods work, they work slightly differently from each other. So some will note that there is a signal of 1, others will not because it's so very close to 0. Intermodes works pretty well, max entropy as well. So if we click apply, now the image is a mask. Now the values are 0 in the dark areas and 255 everywhere else. So at this point, we can interact with the image as if it were a mask. So what can we do from this? We can, if we pull up the Biovoxel extended particle analyzer, do some neat stuff. Where's the Biovoxel particle analyzer? There we are, the extended. So for those of you who, does anyone not have Biovoxel installed actually? Let me start with that question. It's under managed update sites near the top. We go to the arrow here, we click enable Biovoxel toolbox, it'll become apparent here as a green cube. We can click and select the particle analyzer. What are we interested in here? So something we didn't encounter yesterday is these, this threshold, these structures have holes in the center where there isn't a signal. How will we handle those with the particle analyzer? Well, we want to check down here. We want to exclude the edges, so guys like this. We want to clear the results just in case. We want to add to manager. And for reference, this phrasing is used a lot, I've seen in Fiji and its plugins. Every time they refer to a manager, they're talking about the ROI manager. But the ROI bit is usually the one that gets chopped off. We want to check this here, include holes. So when it's running through the image, segmenting the different structures, it will make an effort and also characterize and preserve the holes inside these structures, but in a kind of roundabout way. So at this point, we can click OK. We see our structures here, but something's wrong. That's because our LUT is inverted. It doesn't always happen to me when I use the particle analyzer, but sometimes it happens unaccountably. We see it's picked up all these things, but we now have more than one image in front of us. we have the original Labkit thresholding segmentation, but we also have this other image that is the whole particles, including the area inside that's filled. What if we wanted to measure intensities only in the areas and exclude anything in the holes? There's very little in there, but still we don't want it to complicate our analysis. Well, the way that the particle tracker works is it measures the outer boundary of the structure, or the particle analyzer rather. It measures the outer boundary of the structure. So it doesn't actually keep any of the information about the internals. However, because we have these masks from Labkit, we can perform a quick set of image math and then get just the mask of those holes. So if we wanted to determine, say, the intensity inside these structures without the intensity inside the gap, we would do a mask with ROIs from the particle analyzer for this image, and then subtract the same process we applied for that image. Any questions at this point? All right, so just to show you what that looks like. We will have process image calculator, yeah. So we have got this one, mask of mask, image 0, and we want to subtract. And we have the residual. We can save the ROIs from these structures for reference. We can empty the ROI manager and run the same analysis here. And that gives us the ROIs for the holes and any speckles in the vicinity. So at this point, we can measure. But no, we actually want to measure on our image of interest. There we are. We hit measure. We can save that data in Excel, in a CSV, however we want, and then later do the endpoint calculations. But this is the way we would do that in. Any questions at this point? Yes.
Can you do this on 3D images?
Segment?
Well, the machine learning, the Labkit.
Yeah. Labkit works on 3D data sets as well.
Would you just like make a max projection, or would you do it like on the actual?
The way it, let me see if I have a, so Labkit can train a segmenter, but that's all it's for. There's no like extensive visualization suite for it. So it's a very specialized tool. Imaris is better though, because Labkit will do this segmentation by slice. So let me pull up a multi-stack image. It's a good one. Fiber. It's RGB. So if we wanted to take a look at a stack with multiple Z slices, a three-dimensional data set. We can do that. Let's see. Yeah. So duplicate. I only want slices. I only want one frame, 5 slices. So this is a small stack, but we can pull it into Labkit. It can handle 3D. I'm not sure exactly how to get it in there quite yet. Yeah. Recordable. So it does bring in the slices, but that's something I'm gonna need to do a bit more research on. I'll need to get back to you. Oh, I mean, the way Tomas was doing it seemed straightforward. Okay, aside from looking at 3D sets, any questions on how to get Labkit open and train a segmenter? Does anyone need some more help? Now that we've gone through a
I think maybe I'm just gonna say this to everybody,
Mhm.
sorry, it's a little bit of a push, but we have workstations with $15 an hour have a Morris. Stoyan also can help you
Mm.
with anything you need help, that's what he keeps saying, consultation. I wanna make sure everyone knows that we have facilities, have software, have all of that, we give free consultations.
For our self-directed exercise, let's have everyone try to do this, but with the DAPI channel, nice clean nuclei. So give that a try. Hunter and I will be going around to answer any questions you have during this. Once everyone's exported their mask from Labkit out to Fiji, thresholded it, made it into a binary, go ahead and run the analyze particles on it. Make sure to check the summarize function. And then we can compare results together. So take a moment to do that, and I've got a count of around 21 with an area of 10,000. Does anyone differ from that? Raise your hand. You have 22? What's your area? Yeah, the total area covered by them. 45, 4 or 5%. Okay, yeah. Mine are only covering 3.8%. So this is something to keep in mind. When you have a trained classifier you're applying to images, it will classify them the same way every time. It's very consistent. If it's trained by different people who haven't compared their annotations, then it can produce different results, but it will produce different results consistently. So it's just something to keep in mind. If you end up using this for a long time, make sure you know how it was trained, so you know any issues that could arise, or anything it may lack because it wasn't quite trained correctly, or it was trained slightly differently than you expected. That being said, if you want to pass a classifier around the lab, make sure everyone knows how it's trained, just so they know what's inside it. but that's good. Anyone get an area below or above 3% or above 5%?
How do you get that result merge into one?
Into one here. So the way I did it was I had the summarize option checked here. And I believe that does, yeah, that does it for the entire image, all of the ROIs. So far this has been an introduction to Labkit, just a taste of how to use it, how to maybe get more experience with it. We are about to move into macros. So before we take a break and then come back for macros, does anyone have questions on Labkit before we conclude with that? Yes.
Is there any limit to the level? Like, can we add level for the training? Or, I mean, just need to be like longer.
Yeah, so you can add additional labels if you have different kinds of structures in the same image. I don't know the functional limit, but I expect 10. You could probably go longer, but the more extreme the use, the more likely it is to fail. I can't really speak to how effective that is right now. But yeah, you can add more labels. I think you can look at multi-channel images. I'm not sure about that, but the software has a very good support documentation on the Fiji website. Up here, this is a very useful document because it guides you, it provides access to resources, it gives you understanding of the theory and then some of the application and examples, yeah. So I would recommend, if you want to know more about those kinds of things, take a look here. Now that we have everyone back, we can get started on the section about macros. So first of all, what is a macro? A macro is a special purpose language, usually attached to some other piece of software like Fiji, or for those of you who've used it, I think the Element software as well has a programming language or macro language internally. And what does it do? What's the point of it? Well, it's less complete than, say, a full programming language, but it does allow you to readily call functions from the software you're using. The Fiji macro language can call pretty much any function you can do by hand, you can call from a macro for Fiji proper. This also extends to some plugins. Labkit is one of them. There are ways to call it from a macro, from a written macro to perform its functions. That's not always the case, and we'll talk about why that is a bit later on. Below here, this page especially is very useful. Basically a complete list of all of the natural macro functions inside of Fiji that you can call. And it's a lot. There's input-output management, and lots of other stuff. Basically anything. You can prompt the users for input if you're looking to work on different types of images with the same macro. You can tell it where to write data, where to read data from, all that kind of stuff. So we'll touch a bit on all of those as we go forward. Why would we want to write such a macro? I mean, if we can do it by hand in Fiji, surely that's enough. But a macro takes some of the repetition off of you as a scientist. It can allow you to process a very large data set. Say you need to make 100 MAC-Z projections or segment 100 images, and they're different images, maybe different samples, but they all follow the same analytical path. You can put that in a macro, and it'll do it in a fraction of the time. Additionally, the macro will always do it the same way. So you doing it, you can make a mistake clicking somewhere, make transcription errors or typos. I do that very often. And a macro, you only need to write once to the point where it works, and then you don't need to do that analysis again unless some part of your situation changes. And that can be very helpful. It can save you a lot of time. But there is an upfront investment in time and effort when you write a macro, so it's not useful in every situation. Like if you're only going to create 10 of those Z stacks on this set of images, but you're never going to look at this data again once you have that, it doesn't make sense to write a macro to do 10 sets of calculations. But this could be scary. We're having to do some programming. How can we make sure, how can we get a start on this? Well, my recommendation is to do it as if you are writing a paper, which is create an outline, define clearly what your data is, how you analyze it, and then what steps you take when you're analyzing it. Because in order to write a macro, we need to atomize all of the steps. We need them down to the most basic level so that we can then translate them into the macro language. So a tool you can use to do that is pseudocode, which is basically, lines, descriptive lines that call a function or that reference something done to the image, and you put them in a list, and then you can go down that list as you're filling out the macro with the proper programmatic language. So in the example here, we would import this image or an image like it in a more general sense. We would threshold with the max entropy method. Here we're defining the function we want to call and the input parameters for that function. We apply the threshold, we create a mask from that image, save that image as a TIFF file, and then run a particle analyzer on it. Then output the statistics, save them, and then close all windows. So that starts our macro, that ends our macro. And as we are going through this part today, you'll get a better sense of what we can actually replace this language with. If we wanted to start writing a macro, we would do so by going to Fiji, selecting plugins, scrolling back to the top, because Labkit is all the way at the bottom. Under macros, record. And what this does is this opens a recorder window. So now every manipulation we do in Fiji will be recorded here. And the way it's recorded is in the actual code that was called to run that operation. So we'll see that in a little bit. We also can go to plugins new macro and open this screen here, which is where we would actually write and make changes to the macro code. We want to make sure that when we are in this image here, we have our language set to ImageJ macro language. Conceivably, you could program in with the syntax of several other languages, but that's only if you know those languages. Would that be useful? Right now, we're just focusing on the ImageJ.pg. What's nice about the text editor here is that it will color code the various components of the code. So it will increase readability, essentially. You're not going to be looking through black and white lines. there. Before we actually start writing code, let's go through some words and some symbology that's pretty common here. Like any language, even a macro language has syntax, has vocabulary in the form of functions, and has a whole sorts of things you could do. Typically, parentheses are used to separate input or to specify input for a function. So the line here, 14, that says select window and name, this is the function we're calling from the macro, select window. And we're specifying the name for which window to select. What this function does is if we had, if we had just any macro or any image, we can select it. And we would see that pop up here in the recorder, showing us what function we just performed. And this is going to be useful in the end because once we perform a analysis pipeline, we directly have a basis for the macro because we can then pull it into the text editor and start changing it to generalize it or to make it behave more specifically if we need that. Curly brackets here, they are used to separate code blocks, such as those you get by creating loops or statements. Basically, if you create a for loop or an if statement or things like that, the curly brackets delineate the start and end of that code section, which will then fall underneath that loop. So that means here, this loop starts with a curly bracket, closes with a curly bracket, and everything inside will only be performed while we are doing the for loop. Quotation marks specify characters. So for those of you with less experience programming, there are different types of variables you can produce and keep inside of the Fiji macro language. And those are generally either numerics, like arrays or individual values, or characters like strings and names. Anything you mark with quotation marks is going to be understood to be a string by Fiji. And that's an important distinction. A variable, as I mentioned, basically is an abstract way to refer to a certain value in a certain place on your system in memory, somewhere inside the computer. So when we work with variables, we're essentially, assigning it a value, and then we're referencing it by name later on. So in the example here, if we wanted to write a string, hello world, we could create a new variable called message and assign to it this value here, hello world. Every line in Fiji needs to be closed off with a semicolon at the end. Semicolon. It's not a semicolon. Yes, it is. Yeah, a semicolon at the end. Because of the way the text editor works, if you try to run a macro and you have some kind of syntactical error, it will let you know. It will also tell you what line it's on. That's good, because it can be a pain to debug very long macros. Numerical value, on the other hand, same process. You have a variable name and you assign it that value. Later on, we can call these and get the words out if we need to. So how that would work, just to give a functional example. We have the variable message. It's hello world. I'm going to use the print command and pass it the variable name. And if we select these two lines, we can go to run and run selected code. And we have it there, hello world. Same thing for total count. Aha, but I made a mistake. We're missing the semicolon here. The semicolon tells Fiji that the line is ended and to go to the next. Sorry, do you have a question? Yeah. Okay, it's all right. So yeah, once we correct that issue, we get hello world. Ooh, total count. Aha, already my typo has made it fail. There we go. We can print out these examples. So why don't, yeah. So far, does anyone have any questions? Does anyone need specific concepts expanded upon right now before we go forward? Excellent. Anyone in the audience? Okay. One of the big things we use in Fiji is, in the macro language is a function. I've referred to a number of things as functions here. And a function is a set of code in your macro or called out from Fiji's macro language to perform a certain operation. Some functions require input parameters. The function open, for example, opens a file, but it needs to know the name of the file. So its input parameter is the file name and its location. If we wanted to set a threshold and we knew the two sets of parameters for that, we could also call the set threshold and enter in those parameters, the minimum and the maximum. But you're wondering, how can I know what inputs a function takes? That is a good question. On this master list of macro functions, you have the function names and then their inputs and the kind of input they need. So we can just look at a few of them. Eval macro, eval script, exit, yeah. What's a good one? Threshold. Yeah. Here we see the threshold function specified and its lower and upper threshold required inputs. We're also suggested some other functions that could be useful. Get. There is one that's really useful. Stack. Yeah. If you are doing something like trying to set a multiple stack slice in your macro to a certain position, you can, for example, call this function, specify it, location in the stack, and it will go there. So it's very complete, very big. I definitely suggest taking a look at it, if only to browse it the first few times. And there are also examples provided in some of these, basically different ways of implementing them in the macro language. Yeah, inputs and outputs can be numbers, characters, or other objects, depending on the function you're calling. The issue that I mentioned earlier, in that not every plugin lends itself to being put inside of a macro, is because I have a hard time finding the input parameters for macro or for plugin functions. So it's difficult. Sometimes they'll be available, other times not. So you will have difficulty either finding out how to call it or being able to call it at all, because that information isn't accessible to you. And while we would want the recorder to record that, it does not always. This might be different, but yeah. So when we call a Fiji function, it's recorded down here. When we call a plugin function, it isn't necessarily. But this one luckily is. So right now, run is the command to run a specific script or plugin or macro for Fiji. So right now we're having run extended particle analyzer, that's the tool name, and the parameters here, show, masks, redirect, none, keep, none, display, clear, add, exclude, include. Quite a mouthful. Something important to notice about these run commands. Both the function name and the input parameters are strings. So if you were to call them in a macro, you would need to find out what settings you need, first of all, and then you would need to properly put them together in a string so that the function can execute. And in my mind, that's one of the more tedious and difficult parts of writing a macro is getting, plugin functions to work effectively, especially if there's question about the input parameters. Any questions at this point? Any clarification you all need? Great. So let's go ahead and use the recorder. Try and go through this list of analysis methods, have the recorder, and then save the results and create the macro. So go through these all by hand with your recorder open. And once it's done, click create to open that in the text editor. And let's take 10, 15 minutes to do that. Make sure you save your macro just in case. This editor does not have autosave, I believe. It doesn't? Yeah, it does not have autosave, so save. Save often, save frequently. But right now, we've written a macro, we've taken in the commands, we've written a macro, we've taken in the commands from our recorder to our text editor, and we've run it, and it's run start to finish. Excellent. However, this macro is only going to run on this one file we opened as long as that file is in that specific directory. So it is at the moment a little unflexible. The next step in the process I typically use is to make it a little more generalized. If I have several files I need to look at, or if I want to use this macro, for different research projects, maybe at different workstations. So we can do that by replacing the first line. Here we explicitly say open nucleus gray. We have to specify the entire directory path. So what's the name? Where is it held? What's the format? You can see that. This one was my users folder, Stoyan documents, ICI stuff, ICI course, day 3, nucleus-gray.tiff. All of that is needed. There is a way to break it down. For example, if you know you'll be working in the same directory, this initial part all the way to the name can be condensed into a variable, then called in later. I'll show you how to do that in just a moment. But for now, let's replace our first line that opens the image, and it may not be your first line. Change that to open, parentheses, no arguments. And then transform line 15 that saves the results as these two labels here. Create a new variable and get the directory, and then add in the line that says save as results output directory plus results CSV. This is in fact how you can also shorten the open location. Like you can just get a directory, set a variable equal to that directory name, and then when you're doing output or input, you can just add it to whatever it needs to finish the name. In this case, since we're saving results as a .csv file, we would just append results.csv. So everyone give that a try. And it looks like everyone is pretty much at the end point. You've gotten to the, has anyone not been able to replace the open and the save as functions yet?
Yeah, I had an issue.
Uh-huh.
I don't think it's recognized actually.
Yeah, so sometimes, I don't try to select this when we say that.
So the results of the
Normally, if it detects that the image needs some questions answered on how it's going to open it, it'll prompt you for it. But the hard code to call it directly in case you can't figure out how to do that. So what you do is you replace the bioformats.
the modified it, and gotten some kind of output. So I'm going to spend a few more minutes just talking about what a good way in which to write your macro is. Then we can take some questions in terms of applications and points of interest. And that will conclude the seminar. We'll end a little early today. So in terms of programming a macro effectively and writing it, I am a physicist. That's what I learned when I was in school. That's how I was trained. And physicists have a very bad tendency to name all their variables A, B, C, X, Y, D. And that is simple as you do it, but it can become very hard to later on go through that code and interpret it. Interpret what it's doing, why it's doing it, and how it's doing it. So my recommendation for that is use descriptive names. They don't have to be very long, but ideally they tell you what the variable holds. That can kind of help you as you go back to it to remember what you wrote, and it can very much help a colleague later on that's working with the old macro to figure out what you meant to do. To that end, commenting is also quite important. And what is a comment? You can see the green text at lines 12 and 22 here in the image. If you place two forward slashes together on a line, that line will become a comment. So Fiji, the macro language, will skip over it. It's only there for the programmer or the user to look and read about what's going on. So I recommend, especially for longer macros, like the longer your macro becomes, the more you end up doing with it, the more important commenting becomes. Just because, even if you wrote it, you come back to it after a few months, you may not recall everything. And maybe you may have to spend more time to relearn what you did here. Comments are really good for getting around that, as are descriptive variable names. So those are both very good. You can always add a comment on the same line, by which I mean comments. Like that is a valid line if you need to comment a little more aggressively. For macros of this size, you probably don't need a comment. It's short enough, it's direct enough, you can probably make your way through it. It's always helpful. Like if you have the patience for it, I would get in the habit of doing it all the time. And lastly, there is, I saw some of you had macros from other places, and at the top of a macro, there's typically some kind of introduction that will explain what the macro does, how it does it, why it does it, who it does it for, and what kind of data it looks at. Again, if you're writing a big macro, I would definitely have a component like that up there, both to remind you, and if you ever share it with colleagues so that they know what they're looking at. Think of it as like an overview for the paper, the same way you have an abstract for a publication. The same way we did, similar to the way we did the pseudocode as well. Anything else? The big list of Fiji functions is very nice. There is also, at the very end, several resources that are very good. This page here, the second link, actually covers some examples of how to write macros and how to use the different types of loops, for loops, while loops, etc. And that is a little bit more advanced than what we can cover today, but it is very important for creating iterative loops or statements. If you want to go through 1,000 data files, you're probably going to have at least one loop in there. But that's it for the lecture. So any questions in terms of potential applications or functionality while you have me here? All right, class dismissed. Yeah, thank you all for coming.